Goals for the new year is to kind of teach myself chemistry. So I've done my first lesson, which is just a 10-minute video section. I wrote notes on it, so I'm gonna read myself the notes that I wrote. Chemistry lesson 1. Einstein proved atoms exist in 1905. There are three molecules that make an atom: the proton, the neutron, and the electron. The proton is positively charged and is a heavy molecule. The neutron has a neutral charge and is the same size as the proton. The electron is negatively charged but has an equal amount of charge as a proton, with nearly no mass. I have an image of the nucleus here. It's a visual representation of all three of these as a visual diagram. The properties of the nucleus. The number of the protons in an atom determines what element it is. The top left number in the elemental square. For example, 79 protons is always gold. 6 protons is always carbon. The amount of protons in an element is its atomic number. I have an example for gold with 79 in the top left corner. This is the element's defining trait. I remind myself again that the protons are the left-hand numerical number, which is the atomic number, equaling protons. So an atom of silver with 47 protons in its nucleus is always an atom of silver, because the atomic number is difficult to change and nearly impossible. Neutrons serve as a partner for protons, providing vital support and connection for the proton. They themselves do not do anything but enable the proton's qualities. Nuclei, which is plural for the nucleus, only clump together permanently when the right number of protons and neutrons get together. I have two examples here, which is two variants of silver. Silver needs about 60 neutrons to space out the 47 protons correctly. Add that 60 neutrons to the 47 protons and you get the mass number for silver as 107. However, it does not have to be 60. Silver nuclei are stable with 62 neutrons. When you add those together with the 47 protons, you get 109. The atomic number of silver does not change when the number of neutrons change. Protons' atomic number are not affected by more neutrons, but relative atomic mass does change. Relative atomic mass does change. Relative atomic mass is the number of protons in addition to the neutrons averaged across Earth. So it is the average of, for example, the atomic mass of both silver isotopes. The thing is, though, is that silver can be stable and remain silver at 2 atomic masses, which I just went over, which was silver 107 and silver 109. 107 and 109, these stable variants are referred as isotopes. Isotopes means same place. Although different, they are still categorized both as silver into one singular element as silver. Their separation is isotopes. They have different atomic masses, but despite that weight difference, they remain silver and retain the same chemical properties. I remind myself one more time that the top left alteration of an elemental square is now including the mass number on the very top, the protons, which is 47 for silver, underneath that, and then Ag, which is argentum, translated is silver. The mass number is just the total number of nucleons, protons plus neutrons, the simple addition of adding the two together inside the nucleus, which is different than the atomic mass. These are the first notes that I've written, and I'll write another section soon.